Everybody to the basics of image generation and ComfyUI workshop. My name is Jeremy Fritzhand and I serve as CEO here at VentureStudio of Ahmedabad University. Thanks for joining our session today. We are recording and we'll be sharing the recording afterwards. So today I'm pleased to welcome Dhruv Khatri. He is an AI catalyst and founder of AppUnik, where he helps founders and technical teams adopt practical AI, from workflow automation and AI agents to LLM-driven tools. With 8+ years of experience leading a service-based tech company, he focuses on turning AI strategy into measurable outcomes through hands-on coaching, enablement, and integration. Dhruv holds a computer engineering degree from Gujarat Technical University and frequently advises on AI for teams, AI for founders, and scalable AI implementation. So please join me in welcoming Dhruv Khatri. Over to you, Dhruv.
Hey everyone, thanks Jeremy for the great introduction. So yeah, my name is Dhruv Khatri, as Jeremy mentioned, and I run a company called AppUnik. So yeah, let me start with the one basic question to everyone. Like, have you used a Nano Banana in recent days or recent past days? Like, I think you may be aware of that. So anyone can raise, like, if you used or you tried that out, or maybe you checked the trend. Okay. So I see a lot of ends there, like you tried and you used a Nano Banana in recent in your past days. Also, you maybe seen a recent trend going like in the Instagram and all the social medias right now. Everyone is changing their clothes and they are wearing the red saris and all those things, and maybe the privacy concerns and all those things. Maybe you are all aware of that. So to overcome that and like how that image is generated, what are the drawbacks there, what kind of plus and minus are there when you generate from the closed sources and when you generate an open sources, and what kind of tools are there, what kind of models are there, and all those things we will go and cover in the session. So I welcome everyone for the in the session. So let me start with the first stuff. How many of you heard about the stable diffusion or a diffusion? Maybe like any of you? Okay. Yeah, Jeremy, I'm aware. Yeah. Okay. Anyone else? Okay. So okay, let me guide you with that one. So what is a diffusion actually? What diffusion means? The diffusion means the process of like how it takes a one like noise from an image and add a noise to the image. There's a two processes. One, like it removes a noise or it adds a noise. So that is a process called, you can call it as a diffusion. And the stable diffusion. Stable diffusion is an open source model which does this process for you on an image. So basically, let me give you a simple example. Like, how many of you have seen the older, like channel, like when you're before, I think around 10-15 years, like there will be a TVs where you need to use a channel. Right now, it's all the like dish TVs and digital cables are there. But whenever in the past, you can see the like a gray and black the things on your screen when there's a no channel or no images coming. So you can call it as a like latent space or a base image. On that, you can do a process and you can generate an image and all those things. So whenever you go with that and process some sort of diffusions over that image, and after certain steps, you can get your desired input. Or else when you are doing a training or any kind of stuff, you can remove the noise and you can add a noise and diffuse that image to like that kind of image. So yeah, you can this is a sample image. So let me go to the next slide. So this is more about like a diffusion process. So whenever you have any kind of image, so whenever you have an image and you pass it to the model or any kind of stuff, it goes to that model. If you have any kind of questions, please post in the chat. I'll try to answer at any time. Or if you have any questions regarding the diffusion process or the image generation process or anything, the topic which I'm explaining, if you have any kind of questions there, please raise a question so I can answer you there as those questions as well. So yeah. So whenever there is a diffusion process, as I mentioned, like diffusion is just like adding a noise or removing a noise. So when you are adding a noise, then it's called a forward diffusion. You can see that there is an image here. Like this is a normal image. And whenever you add a noise here, it got distorted. When you add a noise again, it got distorted. When you add a noise again, it got distorted. And it will be like a image which is not you can't identify that image, and at that time you can consider it as a completed for a diffusion process. And whenever you want to generate back the image, you can remove a noise from a specific latent image, and from you can remove multiple steps, and after that you can get the desired input or a desired output as an image. So this is a basic like a terminology of diffusion stuff, and how the image process, image generation process goes on. Like if you if you have any kind of questions or you don't understand this, keep that in mind. There is no issue with that. We will see how the diffusion process goes in, and when we go with a live demo with the ComfyUI stuff and the image process, the entire stuff. But this is a general understanding how the image process goes on. So whenever you are doing let me give you a more understanding here as well. So whenever you are doing a forward diffusion, at that time you can call it as a training. So what happens, maybe I think you all maybe heard the words or like a training a model or that kind of stuff. Maybe you all heard those things, right? I think you all heard those words in recent days. So whenever any process happens, there is a base model, like a stable diffusion is a base model, you can count it as a base model for now. Whenever you want to generate a specific kind of images, right now, what happens with the nano banana or all those things, they are trained on their images and their models. So whenever you try to do like a 3, 4, 5 steps on your same image, what happens after a fifth or sixth image, it got distorted, or maybe you can get a different face, different structure and all those things. But whenever you train your model with your only face or your only specific image, a set of images, it gives a same image or similar kind of images which matches your face and which matches all your like you can say your eyes, nails, and all kind of stuff, and hand gestures and everything. So it happens like that. So if you want to generate an image based on your specific category or criteria or for your specific product or all those things, you need to use an open source model to train your based on using a you can train using your own data sets and everything. So this process calls out training, and you can call it as a forward diffusion as well. When you have an image and you apply noise and that image got distorted, and like the model gets it like understanding like, okay, this is the image and this is the way I need to understand, okay, whenever this kind of image comes in or this kind of keyword comes in, I need to apply this kind of noise. So this is how the training happens. So let me give you a more understanding about the training part and the noise stuff. So maybe I think after this a basic understanding or introduction, maybe you will have a questions like what is a noise, how the noise works, like how the noise, what happens when you have when you apply noise, how you predict a noise, and all those things, right? So the noise is like whenever you are when you train your model, the model predicts like what amount of noise is required, and it is done by a noise predictor, and you can consider as a UNet or neural network or that kind of stuff. Based on that, it will understand this amount of noise needs to be applied, and after certain steps it will get distorted, and it will keeps that in their like a mind, like, okay, model will keep that stored somewhere, and whenever you ask for image generation, then takes that noise and apply to the like a distorted image and apply that noise again and again and again to generate the similar kind of images. So this happens when you have a noise predictor like this. This is what noise predictor do. And this is what a training is and noise predictor does. So whenever when the VA is used to just generate this kind of stuff. So VA is a tool, or you can consider it as a node from a ComfyUI, which do all these things. Like it decides like which noise predictor, which noise needs to be applied on the image and how the images will be generated. So yeah, this is how it happens. So okay, now I think maybe you all will have a questions like how the prompt will work. Like whenever we give a certain kind of prompt, or when we give a prompt to any kind of model, how it understands like which kind of image we need to generate and what needs to be there in the image. When you say, okay, let me give you an example. Like you can say, okay, dog with a hat, or dog with a suit, or cat with a suit, or any kind of stuff. Like how the model will understand. So like what happens here, this is called like what happens here, like when you are training the model, you supply an image of a dog, and you say this is a dog as a training model. So at that time, what model will do, model will keep that dog as a word, and that specific noise allocated means assigned to that specific word, and store it into the model's training data, or else it trains over to that. So what happens when a user requests for a dog, it goes to the model, it checks, okay, these are the tokens, and this is a text allocated to this specific noise. It takes that noise and apply that noise to that image, and it will generate the image after that. Same way, but maybe you get a questions like how they will know, like if I say each and every language there's a different kind of names. Like if I have like in a like Hindi, Gujarati, English, everyone say in a different word. Like a dog has a different like words, right? So what happens, a model, like every time whenever there is a model, there is a tokenizer, what it does, like it takes that word and assign a specific number to that, and after that number is like embedded with that specific noise, and after that this process goes on and on and on. So this is how it happens in a at a programming level. So you can simply say whenever, yeah, when you enter a text, it goes to the tokenizer gives the like a specific token. After that, goes to the embedding, and after that it finds out all the noises, like which kind of noises are there for that specific stuff. It combines all the things, like all kind of tokens you passed, and after that it predicts the noise, which noise needs to be applied to the image, and after that it will be generated the stuff. So like for the entire stuff which I said in like past 20 minutes or 15 minutes, this is a visual representation of it. So first of all, whenever this is a prompt, okay, whenever you say a dog wearing a hat, right, it goes to the clip model. In clip model, there is a tokenizer, and tokens embedding will be present. So whenever you add a prompt, it goes to there. It finds out all the details, like all the tokens, and it gives you the noise. It will predict a noise and all those things, and it takes it from here. It goes to the embedding. It in an embedding, it takes like the latent image and all those things, and after that it goes to the unit. This in a unit area, this is where your a noise applies. Like whenever model runs, it goes on and on and on and on, and there are multiple steps happens here, and after that you get the output image. So this is a Gaussian noise. So whenever there any if you are generating an image, the initial image will be like this. Every image looks like this. It goes to the unit, and that noise will be applied to this kind of image, and after that, whenever there is a decided step completes, and after that you can decode that, you get this kind of output image. So this is the visual representation of the stuff which I said in last couple of minutes. So let me stop here, and I think anyone has any kind of questions or anything in this stuff, because this is a purely theoretical stuff. In a couple of minutes, after a couple of minutes, we'll go to the practical stuff as well, how the ComfyUI works and what kind of stuff will be there. But I just want to understand, like, okay, do you have any kind of questions or anything? for up to this. Okay, I think it looks like no one has any questions. Okay, I think everyone understood. So, okay, now we are talking about the open source models and closed source models, which I mentioned. Like, okay, if you are using a Nano Banana or like a Mid Journey or any kind of stuff, those are the closed models where you don't have access to their code or any kind of stuff like what they do in a background, how those are trained, what kind of images were there, or any kind of stuff, right? But here, like there are open source model as well, like the SDXL, FLUX, LoRa, all those things are there, where you can train your like you can train those models as per your requirement, and you can generate images accordingly. So why this open source models are useful, right? I already mentioned in the past, like whenever you use any closed source models, like a Nano Banana or a Midjourney, whenever you are applying a prompt to them, like they might understand or might not understand what you're looking for. And whenever you are applying on your own image or a specific image, they might get like they might get changed, or they will change the structure and all those things whenever you say that. But here, when there is a open source model, you can train your those models using your images. So whenever there is a generation happens, it will be similar to your product like criterias and all those things. It will stick to that, and it will feel that, and it will be generated similar to that. So this is something like that. So there are two major open source models are available in the market. There are lots of models available, but if you like, if you go into the, I can say Civit, if you go to the civitier.com and go to the models tab, there are lots of model available here. Like this all are models. Like if you just go there and see like all these are the models, and you can use this all models to generate an images on using the, you can use this all models, and you can use in the ComfyUI and go to there, and you can just import those models, and you can use those models and generate an images according to that. So there are lots of models available there, but there are two major models are there, SDXL and FLUX, where you can do a training and you can build certain your small models over it, and you can train your stuff, and you can generate ads, your product images, all those kind of stuff. So these are the comparison stuff, like the image quality, how the image size will happen, the text understanding, how it understands well, what kind of problems are there, the artistic styles, text to images are possible or not, and all those things. So yeah, I'll share the PDF as well with everyone, so you can have a look and see like what's happening there and stuff. So yeah. So now let me go to the what is a ComfyUI, why we are using that for an image generation, what are the ComfyUI nodes, what are the workflows, and all those things. Like how many you are aware about the NA10 and the stuff? Like have you used an NA10 in your past? Like just to, maybe you heard about an NA10 or any kind of stuff? Okay. So it's similar to that, but for an images, you can count it that. When you go to the ComfyUI.org, like it is easy to set up. Whenever you can just go to, you can download it for your local machine. If you're using a Windows or Mac, they have all the configurations. If you don't want to download it directly, you can go to the GitHub page, and they have the installing steps and everything. You can go install and do the stuff. But for this, you may need a higher configuration of the GPUs and stuff just to run it up. So to find an alternative, we have something called Jarvis Labs. So let me give you a basic understanding what Jarvis Labs do. Jarvis Labs gives us GPUs on a rent, on an hourly basis. So we can use that GPUs to generate our images. It's that easy. So let me guide you like on how the Jarvis Labs process works. Okay, so whenever you go to the Jarvis Labs, you just need to add a credits. I already have those credits. When you go to the templates, if you find the templates here, if you can click on here, or you can click on the templates here as well. So whenever you go to the templates, they have a pre-created template for the ComfyUI. So whenever you click on this, it will ask you which kind of GPUs you want to use. These are the hourly rates. If you like, so it is an hourly cost like 39.69 rupees an hour. You can rent this GPU, and here are the configurations of the GPUs, what kind of GPUs you can get. So if you're trying and you are getting familiar with the ComfyUI stuff, I suggest you can go with the RTX 5000. But if you want to generate a like a pro kind of stuff or that kind of stuff, you can go with the A100 or RTX 600 era. But if you are learning and you are using this kind of stuff, then you can go with the A500 Pro or maybe an A6000. So you can try that out. So you can select the GPU. Here you can create a storage and you can launch the instance. So what they will do, they will just do a basic preparation and give us like a ready ComfyUI setup. So, but yeah, there is it's an open source stuff, so anyone can use it. You can just go and download it, and it will be downloaded on your system, and after that, it will starts running. So from now, I'll show you like how the ComfyUI structure looks like, what kind of nodes are there, what kind of image generation happens, and all those things once it's allocated, and I'll show you after that. But yeah, like when it's loading, anyone have any kind of questions or anything? Maybe any question, like anything you feel it's not good, bad. Maybe if I'm saying something wrong, or maybe I'm not explaining properly. Yeah, you can tell that too. Okay. Yeah. So whenever your instance is loaded, it will be presented like this. Okay, so what is the difference? I noticed the one question. What is the difference between open source and closed source? So the open source models are those where you can use their code. You can train those models with your data set. You know what they are doing. You have all those access and everything. So those called an open source. When you say closed source, for a closed source, you don't have access to their model. You just go to their portal, type it down, and they will give you a response back. That's it. Like you can consider when you are using a Gemini or for a Nano Banana or else a Chat GPT or else a Mid Journey. So when you go to their portal, it will automatically just generate the images when you give a prompt. It will not say what they are doing in the background, what kind of stuff they are doing, what kind of process they are doing. You don't know anything. But for an open source stuff, you can understand everything what's happening to your image when you are passing when you're passing your prompt, like how it went, what kind of stuff it took, what process it did, and if you want to alter those processes, you can do that to generate a different kind of images. So that those are the open source stuff. Hope I gave you the answer of your question. Or do you still have a question to that? Okay. So yeah, so back to this. So now it's running. So here you will see these three things: Jupyter, VS Code, and API. You can go to the VS Code as well when you want to install a new models and stuff. But yeah, right now we are going with the API stuff. When you click on the API, it will open the JavaScript notebooks and open the ComfyUI structure for you. So whenever ComfyUI loads, it looks something like this. Yeah, you can close it for now. Yeah. Okay, let's just change the. Okay. Yeah. So this is how ComfyUI looks when it is loaded first time. It looks like this. So let me go back to the generation stuff which we understood. Okay. So this is how it happens, right? So this is a basic structure. So let me attach everything, like guide you like what clip model, what is this unit entire stuff, what is a VAE, what is a Gaussian noise, what is a text embedding, all those things. So when you go here, you can see that like there is a load checkpoint, text encode, empty latent image, VA say, okay. So let's go with the one by one stuff. Okay. So first, like a clip model. So you can see that there is a load checkpoint and there's a clip outside. So every time if you use any10 or any kind of like this drag and drop tool, you can understand on a left side, it's always be an input, and on a right side, it's always be an output stuff. Okay. So what happens, like you can consider this. Okay, let me create a new one, and I can get, okay. So this is when you start with the empty like a workflow, it looks like this. So whenever you want to add any kind of node, you can you can right click or you can double tap. So this node pop-ups comes in. So let me start with a KSampler. Okay. So this is a KSampler. In an ComfyUI, it says a KSampler, but in our terminology, you can consider this entire stuff where the latency is taken, unit, there is a conditional latency, and the scheduler. This entire stuff where all steps happens. Like when there is a empty image, this do like a continuous removes the noise from this image and try to generate the desired output. So this is that. Here you can see that there are steps which I mentioned, like the number of steps it applies to generate an image. So number of steps it removes, like number of times it removes the noise from the noise image, and based on that. So here, if you're familiar, you can just drag and drop, and it will show this kind of options, which are the available options which you need to do for a model. Here are the positive prompts. Here are the negative prompts. Here is a latent image. All these things. So let me go here and guide you from here as well. It is because it is a generated workflow. So yeah. So here, this is a load checkpoint. Let me start with this first now. So load checkpoint is a checkpoint where you decide which model you are going to use. So here I just change it to the Juggernaut model. So you can use that. This is an SDXL model. You can use that, which I mentioned, like SDXL is an open source model, and this already preloaded by Jarvis Labs inside the code. So you can use that model directly to the generated images. After that, these two are the prompts. So first one is a positive because it is attached to the positive one. And the second one is a negative one because it is attached to the negative one. So maybe you are aware about the prompting, right? If you are not, let me give you what positive prompt means and what negative prompt means. Positive prompts means what you need in your final output. And what negative prompt means? Negative prompt means what you don't want in your image. So you can see that here we mentioned text and watermark we don't need. Here you can see like we need a one specific glass of water landscape and all those things. We define what kind of stuff we need. And those positive and negative prompts are attached to positive and negative node. Here you can see that there's an empty latent image, which I already mentioned. Like we need this image to get this desired output, right? So we need this. We need to pass this image to get the output. So here is the latent image. So what latent images? Maybe you have that kind of question, like why we are using a latent image? Why you are not using a pixel image, right? So what pixel images? Pixel images, the like it has an entire pixels representation, but latent image is a smaller version of a pixel image. So it is like if you say it's a 512. So it is a smaller amount of latent image. So it will just reduce the size of the image and it generates that kind of stuff. So this is a latent image. So after once the model generates the stuff, it gives the latent image outside. So we need to use a VAE to just convert latent image to the pixel image. So that's why we added here as a VAE decode. And the save image. Here I insert, yeah. So here, let me run the workflow now. So just to see how it functions. So when you press a run, it shows a green outline for the steps, which is it is generating. And this is the final output, which we got. I hope everyone is able to see the final output. Yeah, okay. So let me say, yes, layman can use this. That's why it's a drag and drop stuff. So what you just need to do is you just need to go and do a bit of practice here, like what kind of stuff you need to do and what kind of image. So this is just a simple thing. which I mentioned, like you just need to type your stuff here, just what kind of stuff you don't want, and based on that you can generate the images. So here you can see like at this area, we will see like how the noise is applied. Let me run it again. So you can see how the noise is applied. So whenever there is an empty image, the empty latent, okay, let me add a preview here. Okay, so initially this kind of image will appear. Okay, so this is the initial image. Here you will see the initial image. Here you will see how how the KSampler remove the noise from this initial image, and this is the final output which we are getting. So you can see that this was the initial image. After that, it applied a number of it reduces remove the noise based on our output, our text input, and it gave this as a final step. So this is how entire image generation works. So yeah. So do you like anyone have any questions here, like for at this point? Or you want me to explain any kind of node or anything? I'll explain it again, like the entire stuff, and after that we'll build like what kind of a flow it is, like what is required and how you can build it easily, and all those things. And you can also how you can use the image instead of this image, and what kind of stuff you can do. But yeah, so let me try some more images. So yeah, here you can see that I see a man standing in the park, golden hour sunlight, and all those things. I gave these things, and it generated the image for me like this. So this was the initial image, and this is the output which I got. So here I use the Juggernaut model and stuff. So yeah, anyone? Okay.
We have a question here. Will you be also showing how to set them pipeline for image to image generation?
Yes. Yeah, I'm about to show that. So let's first let me complete this first, and after that I'll explain like how the image to image generation works. The second one, can we run this locally? Yes, you can run this locally. As I show in here, like on a GitHub, you can just directly go here and you can do a setup. If you don't want to do, you can just download this one. They have the options for Windows and Mac, and you can just directly download it here and you can use it on your local machine. There's no need of to go to the Java Labs. You can directly use it on your local machine.
How does
Okay,
it,
so
if we run it locally, do we have to, is it just run like any other application, like the window you're in here?
yeah,
Okay.
it's the same like that. So
Okay.
it will open the same structure, same stuff. But yeah, when you're running on a Windows, you might need a higher GPUs because it's like dealing with images. So you need a GPUs. But when you're running on a Mac, you can get it working for base level models like the SDXL 1.5 or 1.1 or 1.5 or Juggernaut or a FLUX or 2.0 and stuff. But yeah, for higher models, you may need like a higher amount of GPUs. So yeah, uh, yep. Okay, can you use this? Okay, so what you can do, like here, when I also noticed the one question, like how we can use this for a fashion brand, right? So what you can do for your fashion brand stuff, like when like there are a couple of more applications that you can use an in painting or all those things in the app when with the KSampler and stuff, we can do a little bit more advanced stuff where you can pass image as an input and another image as an like your model image. You can pass it two images and you can combine those two images and generate the output. So for your fashion brand, what you can try, you can use the model image and your different VS directly to it, and you can generate the multiple outputs or multiple positions. When you try this same with like a closed source models, you maybe get a output like how they prefer, not how you prefer. So here you can pass all those stuffs by your own. So you can add a multiple nodes, multiple model, multiple like inputs and stuff. Like this is a background I want. This is an image of a model. This is a like the cloth image and all those things, and you can pass all those images in a one go, and you can generate those things. But it is a bit complex where you need to understand how inpainting works, how other like control net works. So you need to try that out. But yeah, on today's lecture, we are only like focusing on the basics. So, but yeah, if I get a chance in the future, like we will do an advanced session on those, like how you can do all those things as well. Yeah, there. I think for you it works. Like for an M4 Pro, it works really well. So you can try this out and you can generate the images and you can understand how good it is when you are generating an images by using this one. So yeah, let me go to the PPT step. Okay, so I explained you like how the ComfyUI works, what are the ComfyUI nodes, like how it functions. So now let me give you a basic understanding about the prompting, how you need to prompt before going to the image to image stuff. Let me give you a basic understanding about the prompting, like when you are generating an images. Uh, okay, yeah, there. I'll answer this question once I'll complete this prompt part. I noticed your question regarding a video stuff. So yeah. So what like here what happens like okay, so there are in a prompting you just need to focus on six different things, right? So you need to pass what kind of subject you want, like if it is a man or a woman or a lion, or you need to give a specific stuff, because as I explained, like each word have that like each word is allocated with a specific kind of noises, right, whenever it's trained. So whenever you pass a specific amount, a specific word or specific kind of stuff, it brings that noise to the like KSampler and runs over it and gives you the output. Yeah. So after that, there is a style. So what kind of style you want? How like it is a photo, like oil painting or cyberpunk or watercolor or cartoon or all kind of stuff. Like a medium, like how it needs to be, like a digital art or a wide shot, or you need to give like what kind of composition you need, what kind of lightings you need, what kind of camera angles you need. You need a close up or a dramatic angle or any kind of stuff, like what kind of stuff you need. Like the additional detailing, you can also give a black and white you want, or 8K you want, or high details you want. You can but you need to define what kind of output you want. You need to pass that kind of input questions or input stuff to it. So whenever there is a like when you are writing a prompt, when you are writing for a prompt for a chat GPT or something, you need to write a sentences. You can write a sentences like, okay, I want this kind of stuff and XYZ. But when you are doing it for an images, what you can do, you can just pass words like, okay, like if you tried a mid journey, I think you can, maybe you are aware like what you need to do. But yeah, so what you just need to do, a male with a white and black clothes, with this in like a professional style, with a wide angle shot in office lightings, and you can just combine these things and you can generate your entire one prompt, and you can pass it to get your desired input, or sorry, an output part. So this is how the prompt structure works. So any questions surround to this? Okay. So here are the some resources. Let me go to each one and I can show you like what kind of stuff it is. So this is a like an explanation like how the prompt works, which I explained. Like, okay, these are the stuffs you need to focus, right? These are the image models and stuff, and these are the subjects and all those things and all the configurations that you need to pass and all those things. So here they have a proper detailing, like what kind of stuff it is there and everything. You can go here and check it out. Like it is already present in the presentation. So what kind of prompt format you need to do, like a list of questions and all those things. So it is a way long book. So you can go there and you can learn how to prompt for an image model. So if you want to get a prompt or you want to try, so you can go this prompt here as well to get a prompt, like what kind of prompt a person gave to generate this kind of images. So you can get it from here. You can copy it, you can try that out as well. Here are also those couple of guides, like what you can do, what kind of stuffs, like all those things, like the same thing I explained. So these are the three tools where you can go and check out, like, okay, this what we can do and how we can generate a prompt and stuff. And how prompt needs to be structured. The main thing is the structure of a prompt. So yeah, so to the side note, this is like as I mentioned, like when you prompt, right, there is a specific word like a line. If we just say line, okay, I have one. This is just a simple like a flow, like you can consider as an embedding projector. So yeah, okay. So if I just say line, so surrounding to line, we got this amount of words. So it checks all these words and checks surrounding word of that too. These are the entire words, like how whenever you train a model and the each and every embedding word will have their own specific understanding and the identification. It contains the like the denursing part and all those things. So it is attached to this area. And it will be like this. This is just a visual representation, how it is stored and how it is linked. But whenever any kind of word occurs in a prompt, what model do, like it goes to the entire embedding, like this kind of embedding structure, and tries to bring that specific denursing pattern to there. And after that, it goes to like it just it here, like it brings that denoising pattern, and after that it tries to apply the number of steps we define. So whenever it do, like it applies a number of times, and after that it finally generates the images, which we already noticed here, like what happens when they do a denoising, like when they remove the noise from the image and all that kind of stuff. So yeah, so here let me give you a little bit more understanding of the KSampler part. So yeah, anyone have any questions, like until okay, yeah. There, I'll come to your questions after completing this, but yeah, about the video part, how you can generate the videos and stuff. So yeah, so here this is a KSampler stuff, right? In a KSampler, there are a couple of points are there, right? What is a seed? Seed means the image, the identity of the image which is generated. So if what happens if I just, okay, let me close this. Okay, so this image we recently generated, right? If we just say a fixed one, okay, this is a seed generator, okay. This is seed, okay, let me just regenerate it once, okay. Sorry. Now our state is fixed. So even if I press a run again, it will generate a same image. You can see that. So each image has their own identity in terms of seed. So when there is a same set, it even if I do anything, it will just do a same image generation. But when it will change, whenever I change any kind of stuff here, so like maybe you see on a Midjourney or all those places, when they say, okay, which kind of image you most like, you can select that image and they generate around to it. So here, what you can try that if you like the image, but you want to like try a couple of more things surrounding to it, but you want this structure. So what you can try, you can just change the denoise or like a CFG or something, and you can just check it out. So you can see that it will do similar to that, but you can see the first image was like this, and here you can see there is a more detail, there are a detailing difference and all those things are there. So it happens like this, but it will not do a more like a changes when you make a more changes in the CFG or denoise, or when you attach multiple images, or like the KSampling and stuff, where you can like after that you can see a major differences here. But yeah, so when SID is fixed, you get the same image every time because it is attached to your image and it will generate the same image. So here you can create keep a randomized stuff, so it will generate a random images every time. Here okay, here are the steps. Okay, let me start with the steps. So steps, which I explained, like here the number of steps it takes, it applies to it do a denoising to generate this image. So here you can keep any number of stuff. Like if we just keep a 2, then you will see how the yeah. So this is after 2 steps. Like whenever 2 denoising applies, like when there is a so after there is a like a 2 times the denoising happens, it generates a like image like this. So if we'll increase to 15, you can see the image, the quality of image. It is improved, but it is not that proper. So in like as a standard stuff, you can use a 20. Yeah, you can go ahead of the 20 as well. Maybe you have that kind of question like, okay, what if I go more than 20? But if you go more than 20, you can get a more detailed stuff. But 20 is a standard. After 20 or 25, you will get a, maybe that like image will get distorted again, because what happens, like it applies a denoising continuously on a same image again and again and again. So maybe it distort the actual image which is already generated. Okay, so yeah, that is a like a steps. The CFG is linked with this stuff, your prompt. So what CFG means? CFG means like how you can say like if you just said okay, like in how I can say in a simple words, like what CFG, like how creative it goes. Yeah, you can say that how creative it goes. So whenever the CFG is low, it goes it will go to a lot of creative stuff. Like it will do everything every time it goes a different stuff. Like every step it goes to the a new creativity. Every time it goes to the new creativity. So you can see that like it will not stick to your prompt. So the like the it will not stick to your prompt what you passed here. So yeah, so I think the 6 to 9 is most generally most of the people use when they want user to be a more creative, like model to be a more creative, as well as stick to the prompt which we passed. But if we just say 10 or 15 or more than that, like it will just do a same thing like what we say. Yeah, it will just stick to that and try to be more aligned to a prompt only. It will not try to be a more creative. So you can say that like if you, yeah. So that is a CFG stuff. Yeah, here the sample name and scheduler, you can try that out different stuffs, but yeah, the normal is a good one. And here is a denoise, like the amount of denoise you want to apply. Okay. So this is used when you use an image as an input for an image to image stuff, image to image video, like as a image to image workflow. But for a text to image, it is not that required stuff. So okay, let me now. Yeah, any questions? Okay, I think there's no questions. Yeah, let me give you an answer to the Dhairy's question now. Okay, so there I think you mentioned like how they create a like more realistic videos, more than 10 12 seconds, right? So what happens, like every model has their own limitations, right? And every time they generate like a 3 to 5 or maybe 10 seconds videos. But how you can generate a more length of videos? What you need to do, you need to first generate an image. You need to take that image as your starting point. You need to generate a 10 seconds video at the end of the 10 seconds. But you can get this control when you are generating and using your ComfyUI or something, or you have a more control on the workflow and stuff. But for a Midjourney and Sora, you can't do that. But here you have a control. So what you need to do after 10, 12 seconds, the 12th second last frame, the videos are the a series of images, right? So at the end of the video, you get the last image. So you need to use that image as a starting point of your next video. So after that, you can just combine those videos. Even if you do that, you can do that in the ComfyUI as well. So you can club those two like images, sorry, two videos, and it will make a single long video from a text to video stuff. So you can try that out. Right now there is a WAN 2.2. Yeah. So right now there is a WAN 2.2 recently released, and you can use that for to generate that kind of videos. It generates more realistic videos as well. So yeah, it happens like that. Now let me start with the image to image workflow. So this is here, everyone aware, like, okay, we pass the latent image, right? So what we here, it is like this empty image. So what happens if we pass the image here? Okay, so let me just try that out. Okay, you can just say, you can just double click and you can search the load image node. So this will allow you to load the image. Okay, so you can choose the image from here. So now what, like now you can see that I can't connect this node because if this, because it is an image that I can connect it, right? Instead of latent image. But no, I can't connect that because, as I mentioned, like the models only take a latent image as an input. Okay, they can't take a pixel image. So we need to convert that pixel image to the latent image. Here, what we are doing, it is giving an output as a latent image, and we are using a VA decoder to convert to the pixel image. So here, what we need to do, here is a VA decode. So here we need to use VA encode to just convert it in the latent image. So here, now we can pass this latent image here. Okay, so now it is connected to our model, and we need a VA that we can connect it from here. And here we can just say, okay, let's keep this image. After that, we'll change the image. Let me change image. I think it's better. Okay. Okay. So I just changed the image, right? Here we have a prompt. Okay. And if I hit run, so what happened? Let's see. Okay. You can see that it combined it didn't give a much information or much combination of the images, right? So why it happens like this? Let me explain. Here we give a denoise as a 1.0. So what it just takes this prompt and try to use it as try to apply 100% over this image. So that's why we are not getting a much aligned to this image. So what we need to do is we need to reduce the denoise. Let's say 6.0.6, and here we can change the prompt like okay. Okay, let's try that. So you can see that it took that image as a base, and now it is applying this prompting stuff over it. So here we got the image. It was like, let me keep both the images side by side, and you can see the difference. It was a more cartoonistic. I said a more realistic. So it says a more realistic. It converted to the more realistic stuff. So this way, what you can do, like you can just combine this kind of stuff. Like you can add the base image here, and after that, you can just convert that image with the prompt, and you can change the stuff. So yeah, here you can try a couple of more prompts to just change the stuff. Like, okay, what do you want to try? And like, okay, let's change. Okay, let's take okay, so just like yeah. So you can see that it added a stars and all those things, but you can see that there is a still the sunlights are there. So what you can try, you can just like add multiple prompts, and you can play with the denoising stuff just to be more aligned with that. Like, okay, let me just change it to 0.7, and what you can see what happens. Yeah, you can see that it looks like a more in a night way. Like you can see there's a moon over there, and the lightings are near to night, and here, this is a purely day stuff. So this is the way you can make the changes and stuff. So here, yeah. Any questions if I move ahead before I move ahead? So okay. Okay, I see there's a no questions around with this. Okay, let me move ahead with this. Like I'm explaining like what ComfyUI, like how you can do more stuff and what kind of things you can do with the ComfyUI more. Okay, so here you can see, you all can see there's a manager tab. So whenever you download a ComfyUI, you set up a ComfyUI, you'll get this manager stuff. So whenever you click on the manager, there are a couple of things you can do from here as well. So there are custom node manager, install missing custom nodes, or model manager, or all those things. Okay. So what custom nodes are? So what happens like whenever there's a new stuff comes in surrounding the ComfyUI or related to ComfyUI, it appears here. Or you can add your own node via get a URL as well. There are a couple of open nodes and the available nodes are there, which you can use to do a specific kind of stuff. So there are, you can check it out like here, like you can go here and you can try it out, like what kind of nodes it is and all those things. So this is the one which I explained, like, okay, what happens like when I want to when I want to apply my own clothes or my own fashion brand clothes to a specific model, then you can try the in painting stuff, which I mentioned. Like you can try to install that in painting. You can use this one, ComfyUI FLUX. You can install it directly, and it will appear same as this node, and you can try that out. Okay. Here you can use the different models. So now, as I mentioned, like here we are using the Juggernaut model right now, right? Here I show you, like here we have a Juggernaut model. Right now we are using the Juggernaut model because it is a smaller one and easy to run. It's a base model. You can try without, you can play without, and the image generation is a faster. But what if you want to generate a more realistic one using a Flux or Flux LoRa or maybe a Flux context or any recent Flux releases, right? Or maybe what if you want to generate on videos? So here you can go to the model. Here you can search, like if you want to search a WAN, you can see there is a WAN 2.2, 2.1 are available right now. 2.2 TTFs are there, T2E are there. You can install this node. You can try this out. You can use that model and you can just run it out from here and just select the model from here, load checkpoint. You just need to you need to change this kind of some sort of structure of this prompt. But yeah, so you can try that out and you can run that and you can generate the videos and images and all those things. Now, how you can export this workflows? Like, okay, I understood. Like, okay, you if you go to the Jarvis Labs, you can't keep this instance running every time, right? Because it costs some money. Like if you are using the Jarvis Labs or any online like stuff. So what ComfyUI gives you, like you can just export the stuff. You can export and they will just say like, oh, how, if you want to export and you can just export. If you just press the export as API, you can also export as an API. Like you can export in any manner. Okay, let me just export one. Okay. Whenever you export, it just downloads the JSON and you can just directly drag and drop the stuff, that JSON, and it will appear here. So it will load everything which was there. It will give you all the configurations you kept it. So you don't have to keep your instance running every time. What you can do, you can just do an export and stuff. But what if you don't want to export or you're getting the images from the okay, from anywhere? Okay, you have this one, right? Okay, this is the image we generated. Okay, so you can save this image as well. Like you can just download this image. It will be like, okay, just let me download it. Okay, so whenever I go to the new tab and I just drag and drop that image, it also brings that workflow. So this is how easy it is, to manage your workflows, to keep your workflows aligned, the generated stuffs and everything. So what happens, like whenever you go to any community pages or community places, you can easily download the images and you can use those workflows directly in your ComfyUI stuff. So this is how easy you can share. You can work on that. You can try more stuffs with that. You can generate a couple of images. You can do an image to image stuff. You can do the video kind of stuff, or you can change the stuff and all those things. Yeah, there. I'll share this workflows with you, and I'll pass it to the Jeremy, and he can share it with you, and also share the PPT URLs with everyone, so everyone can go and check that out as well. So yeah. Any questions like surround to this, or anyone want to understand any point or anything? Because I feel I already covered a lot of things. If I try to cover more things with this stuff, I feel everyone will not able to understand like what is happening and how they can set up. Maybe they miss certain points here, like okay, this is good or bad, or how they can connect, or like what specific node means and all those things. So yeah, but yeah, any kind of questions or anything? Okay. Thanks everyone. So I think yeah, Jeremy, we can conclude from here. Like okay, but yeah, you can connect me over a LinkedIn, or you can go to our website to connect. But I think you can, if you want to connect and you want to learn more, we can connect over a LinkedIn. You can have our discussions. You can ask me any kind of questions if you have in your mind. So yeah, that's from my side.
Awesome. Thank you so much, Dhruv. We can open it up now for some questions. If anybody wants to come off mute, has any questions about the workshop today, about any of the workflows, the tools. Otherwise, we will upload the recording to our YouTube page, and we'll be sharing it out with the audience on our LinkedIn. So thanks again, Dhruv. It was a great workshop. I already got some messages from folks asking for the link. So we hope to host you again in the future.
Okay, sure. Thanks, Jeremy. Yeah.
All right. Thank you. Thanks, everyone. Have a great rest of your day.
Thanks, everyone. Bye. Have a nice day.